After form of Biot-Savart's law. If a charge is moving, say if a positive charge is moving along a straight line. Look here, if positive charge is moving along a straight line, it is equivalent to a current. It will create a current. And now magnetic field due to moving charge at a distance r can also be calculated from Biot-Savart's law, and this formula will comes here mu naught upon 4 pi and equivalent element of IDL. I will be equal to what? dq upon dt, and this is what? dl. Are you understanding? So this dl upon dt must be equal to v. dl upon dt must be equal to what? V. Now your equation will be dq. dq means here q, and dl upon dt will be equal to what? V cross r upon modulus of r q. Are you understanding? Or their magnitude can be written as mu naught by 4 pi q v sin theta upon what? R square. Now this is magnetic field due to a moving charge. So Biot-Savart's law is applicable for finding magnetic field due to a current element. If you will extend this law for arc and a straight line, then we may have different results. So look here. Okay. So if you will find the magnetic field due to an arc, current carrying elements is in the form of arc. Are you understanding? Then what will be magnetic field due to that? This is our arc. This is our arc. Now we have to find magnetic field due to this arc at the center. Are you understanding? So if you consider any arc and it has an element dl, current flowing in it is I, then the magnetic field due to this will be what? Here the r vector will always be perpendicular to I dl. So here the magnetic field can be written as integration of mu naught upon 4 pi I dl, and then angle should be taken as sin 90 degree upon r square. Are you understanding? And the value of sin 90 is what? 1, and the integration of dl is just length of this arc. So this magnetic field can be written as mu naught upon 4 pi I l upon what? R square. This is your magnetic field due to an arc. Magnetic field due to an arc will be equal to mu naught upon 4 pi I dl upon r square. As you know, in circle theta is equal to what? L by r. So if theta is given, then L should be replaced with r theta. So 1 r will cut from here, and your field will comes mu naught upon 4 pi I theta upon what? So what is the magnetic field due to an arc? This is mu naught upon 4 pi I l upon r square, or mu naught upon 4 pi I theta upon what? R. If you will extend this arc to a circle, then due to circular loop, this is asked, due to this circular loop, the magnetic field at the center will. Are you understanding? So for a circle, L must be equal to what? 2 pi r. L must be equal to here 2 pi r. What are you doing? Second bench. Keep silently. So L must be equal to here 2 pi r. if the radius of this circle is r, then we can find magnetic field here, and the magnetic field at the center of circle, magnetic field at the center of circle can be given as mu naught upon 4 pi, and now L will be equal to what? Total length of the circle is what? 2 pi r. Are you understanding? Total length of the circle is equal to L upon 2 pi r, and this is 2 pi r upon what? 2 pi r upon r square. And if you cut all these terms, then you will get here I dl. So this is mu naught I upon 2 to the 4, this is 2r. Magnetic field at the center of circle is given by mu naught I upon 2r. Here you can see that magnetic field is inversely proportional to r, and there is I upon mu naught I upon what? R. Dimensionally, one dl terms is removed from here, so one dimension of r should be reduced from below also. So you shouldn't commit mistake I upon r square. I dl will be anywhere, then there will be r square in denominator. If dl terms will be removed, then dimension of r will also reduced. Here dl is present, il is present, that dimension is what? R square. And here L is removed, theta comes, theta has no dimension, so here dimension of r is also reduced. So you will never commit mistake, because in formula there will be r square, r cube, different form. Magnetic field will be mu naught I by 4r, 4r square, 2r, 2r square. This objective will be formed. So you shouldn't commit mistake from here. Are you understanding? So this is magnetic field due to an r. From Biot-Savart's law, this question is your BBI, asked for long question, but I will not discuss long question here. So here it is given a ring. What is this? This is a ring, and you have to find the magnetic field at a distance r from here. Say this is magnetic field, the radius of the circle is a, and this distance is x or r, you may consider anything. Then there this line days, distance of this line days must be equal to that. If we will take r, then this will be x square plus what? A square. Now magnetic field at the axis, this is called magnetic field at the axis. Magnetic field at the axis of circle is given by magnetic field at the axis of circle is given by what? B must be equals to mu naught upon 4 pi, mu naught upon 4 pi, that can be written as 2m upon r, 2m upon r. Are you understanding? This is very short formula. Are you understanding? B is equal to mu naught upon 4m, 2m upon r square. Now what is m? Here I have taken new terms m. M is here considered magnetic moment of this loop. This is also objective. What is the magnetic moment of a circular loop? Magnetic moment of circular loop. Magnetic moment of circular loop is given by m is equals to I into area of the circle. I into area of the circle. And here the area of the circle is I, and this is pi a square. What is area of the circle? The area of the circle is pi a square. I is equals to pi a square. Are you understanding this? So here m is equals to what? I into pi a square. So B can be written as here mu naught upon what? 2 I into pi a square upon r. R is written as what? X square plus a square. Sometimes in detail it can be written as x square plus a square This is power 1 by 2. This is power 3. So this power can be written as 2 upon 3. And this is for one turn. If number of turns will be increased, then fill will be multiplied what? N times. If n turns will be there, then fill will be increased n times. So you either take this formula to find the magnetic field at the axis of circle, or you use this formula. From here to 3 objectives is covered. One is what is the magnetic field at the axis of circle, and if data will be given. Do you know the value of mu naught upon 4 pi? I have not discussed this. What is the formula of mu naught upon 4 pi? 10 to the power minus 7. This is 10 to the power minus 7, and their unit should be what? The magnetic field. Look here, magnetic field B, and this is mu naught upon 4 pi ideal. Here one dimension will cut, so this will be Tesla meter per one dimension of I will come ampere, Tesla meter per ampere. The value of mu naught by 4 pi. This is also one object. You should remember it. What is the value of mu naught? What is the value of mu naught? Mu naught will be 4 pi cross 10 to the power minus 7 Tesla meter per ampere. Are you understanding this? So your value of mu should be known. You can look here. This is same as the magnetic field due to a dipole at their axis. This is same as that of magnetic field due to a dipole. Are you understanding? And magnetic field due to dipole, magnetic field due to a dipole. And you should understand here, we will learn about the magnetic properties of material, but here you should understand it. A circular loop is equivalent to a dipole, a magnet. It will produce you a magnetic field. Circular loop is equivalent to a magnetic dipole, and due to dipole the magnetic field at the axis, due to electric dipole the magnetic field was what? 2 kp upon r cube, or we can say that 1 upon 4 pi epsilon naught 2p upon r cube. If you compare these two results, then you will find that a circular loop also acts as a dipole. This is your electric dipole, and this is your here what? Magnetic dipole. And this is magnetic moment, I into A. One question is from here, what is the dimension of magnetic moment? What is the dimension of magnetic moment? The dimension of magnetic moment will be ampere into meter square. Dimension of magnetic moment will be ampere into meter square. Are you understanding this? Ampere into meter square. The dimension of magnetic field is ampere into L square, and the unit is ampere into what? Meter square. The unit. Very simple. M is equals to IA. So here two dimensions will be asked. One dimension of magnetic pole strength. This is ampere into meter. Dimension of magnetic moment. That will be ampere into meter square. A dimension of magnetic field I have calculated, F by IL. LL will cancel. So M A inverse T to the power minus 2. And dimension of mu naught, force upon ampere square, ML T to the power minus 2, A to the power what? Minus 2. Permeability. Don't mistake between permittivity and permeability. You should remember that. Are you understanding? So all these formula are for based on what? Biot-Savart's law. One more question may be asked from here. The magnetic field due to a single turn is B1 at the center. What will happen if this will make n turn coil? If there will be n turn coil, then the magnetic field due to n turns is increased by n square times of what? V1. It can be proved, but it is an objective here, you should remember it. So this is magnetic field due to arc, circle and at the axis of ring. All these questions are based on Biot-Savart's law. One concepts are remaining here, magnetic field due to a straight wire. Okay, so magnetic field due to a straight wire can be calculated as magnetic field due to a straight wire can be calculated as given from here alpha and beta, and I current is flowing through having finite length. Infinite length can be calculated from Ampere's law. From after Biot-Savart's law, we will discuss the concept regarding to what? Ampere's law. Are you understanding? Then force acting on current elements. Understanding this? So this is magnetic field due to what? A straight wire. And here the magnetic field is given by B is equals to mu naught upon 4 pi I upon R sin alpha plus sin beta. Very symmetric formula, and you should remember it. The magnetic field due to a straight wire due to a magnetic field due to a straight wire is given by B is equals to mu naught upon 4 pi I upon R sin alpha plus sin beta. Are you understanding? If the wire length will increase and it goes to infinity, then beta will tends to 90 degree and alpha will also tends to what? 90 degree. In this case, the wire become infinite. Wire become infinite, and magnetic field due to infinitely long wire may be taken as B is equals to mu naught upon 4 pi I upon R, and this is sin 90 plus sin 90, which will be equals to 1 and 1, 2. And this is 2 2s are 4. So B can be calculated as here mu naught I upon 2 pi R. Same result can be obtained from Ampere's law, which is very fundamental law. Ampere's circuital law or Ampere's law. Ampere's circuital law or Ampere's law in magnetism. This is very fundamental law, and it is equivalent to Gauss law in magnetism. With the help of Gauss law, we can find the electric field, and with the help of Ampere's law, we can find the magnetic field. Are you understanding? So, what is Ampere's law? Tell me, anyone. This is B dot dl must be equals to what? Mu naught I n CL. Line integration of magnetic field over a closed loop. Line integration of magnetic field over a closed loop will be equal to line integration of magnetic field over a closed loop will be equal to what? It will be equal to mu naught times of current enclosed by the loop. And from this law, you have to find the magnetic field due to an infinitely long wire. Are you understanding? You should remember that result. So here, if wire is infinitely long, then you take a circular curve. Ampere curve will be what? A circle. Then there Ampere curve will be a circle. And take a circle of radius R here. Take a circle of radius R here. Are you understanding? And now the value of D dot dl, D will be D, and dl means what? Length of this circular loop. dl is the length of this circular loop, and this will be equals to what? 2 pi r. P into 2 pi r, and that must be equals to what? Mu naught r. Are you understanding? So from Ampere's law, you can find the magnetic field due to infinitely long straight wire, what you have derived earlier. And this is very simple derivation, and from this derivation you can look here, your field is mu naught I upon what? 2 pi. You can compare this result with in electrostatics with a straight wire having uniform charge density lambda, or there is a hollow or solid cylinder having uniform charge density lambda. We have studied in what? Electrostatics. Look here, there is similarity in formula. 1 mu naught is equivalent to 1 by epsilon naught. Mu naught is equivalent to, you can see epsilon naught was in denominator, pi, QINCL upon epsilon naught. Here mu naught is up, so there is inverse. 1 upon 4 pi epsilon naught. Here mu naught upon 4 pi. So inverse types relations. Are you understanding? So here you will find that the magnetic field, the electric field due to a straight wire at a distance r is E is equals to lambda. Lambda I will be equivalent to what? Lambda, and mu naught will be equivalent to 1 upon epsilon naught. So lambda upon 2 pi epsilon naught r. Can you remember this? This is electric field due to a straight wire outside. This is electric field due to a straight wire outside. Are you understanding? This is electric field due to a straight wire outside. Are you understanding? And the formula is similar. Mu naught is at up, so epsilon naught will come below, and equivalent terms of I is here lambda. So this is lambda upon 2 pi epsilon naught r, and this is formula of what? This is formula of electric field due to infinitely long cylinder, hollow, solid, or a straight wire at a distance r from the axis. Are you understanding? And here the magnetic field is also mu naught I upon 2 pi r. So both results we can remember or not? Both results we can remember easily. Are you understanding? Now from this law, you can find the magnetic field inside the hollow cylinder that carries current I along its periphery. That carries current I along its periphery. And formula will be same. Outside the formula will be same. Outside the formula will be what? At a distance r. But inside the magnetic field will be 0. Similar as electric field is 0. Because no current is flowing through inside. This is hollow cylinder. This is last bench. This is hollow cylinder. Are you understanding? So in a hollow cylinder, the magnetic field at a distance r from the axis is given by B is equals to what? Mu naught I upon 2 pi r. So similar result. If there will be a straight wire or cylinder, or outside the cylinder, or straight wire, or solid conductor, outside the field remains same. This is same for hollow, solid, and straight wire. Outside there is no difference. Inside there is difference. Inside, if it will be hollow, then electric field will be 0, and if it will be solid, for solid the dimension is increased. Solid dimension is increased because field become proportional to r. Are you understanding? So for solid sphere, the field will comes here lambda r, and dimension of r will increase here. So it is 2 pi epsilon naught what? R square. Very easy. You can remember it. This is very easy formula. Are you understanding? Now look here. This is hollow, so the formula is same. Inside is 0 and outside mu naught I upon 2 pi r square. If it becomes solid, that formula will change only inside the sphere, inside the cylinder. Outside the formula will be same. Whether it will be hollow, solid, or a straight wire, outside the cylinder formula will be same. and inside it will linearly vary with r. Inside it will linearly vary with r. So you can remember it very easily. Increase the dimension of r in numerator and denominator. So you will get here formula mu naught B is equals to mu naught I r upon this should be the capital R 2 pi. 2 pi, this is r, but this should be capital R square. Now magnetic field is directly proportional to what? R. There is a comparison. If electric field or magnetic field will be asked, if electric field or magnetic field will be asked inside the solid sphere or solid cylinder, it will be directly proportional to R. It will be directly proportional to R. And outside the cylinder, it is directly proportional to 1 by R, whether electric field or magnetic field. And there is no spherical concept here. So due to a sphere, the electric field outside the sphere was proportional to 1 upon R square. And due to dipole, the electric field was proportional to 1 upon R cube. Whether electric dipole or magnetic dipole, the field will be proportional to 1 upon R cube. A current carrying loop acts as a dipole. So Ampere's law is clear. With the help of Ampere's law, you can find the magnetic field due to solenoid as well as toroid. And their brief discussions, you can see here the brief discussions, means in short space you can find the electric field due to what? Solenoid and toroid. Do you know solenoid? Solenoid is what? Anything, any say marker, and there will be lots of winding on it. Copper wire, take a copper wire and wind on it, which will act as a solenoid. And magnetic field due to infinitely long solenoid at the axis. This is your solenoid, and these things will be what? Toroid. Are you understanding? And magnetic field at its axis is equals to what? B is equals to what? Mu naught. And everyone know this. B is equals to, if you will take derivation in short, so take here Ampere curve ABCD. If I current flowing in each turns and there is number of turns, N is equals to number of